My name's Mark Gunnels. This talk is about an open source database, Neo4j. It's a graph database, so we're going to kind of go over some high-level graph concepts. Not going to get too deep into that. I did a version of this talk where I did, and then I also used Clojure, and everybody just left. It was awful. So we're going to talk about Neo4j, graphs, and then Neo4j has created this language Cypher that is essentially it's a declarative language for querying databases. It's essentially the sequel of graph databases. And it's fairly simple to understand, so this whole talk, simple. We're going to power through. Again, I'm Mark Gunnels. It's almost a company now. There's a bunch of legal stuff that I hate dealing with, but I work for ATO2013 Labs, also for Jack Russell Software. That's my real job. Hi, boss. 221labs.com it's essentially a blog. There's only 2 blog posts. There's like 3 or 4 lined up. And the 2 blog posts only like 0.0001% of the population care about. It's Clojure script. And then that's me on Twitter. So, all right. I run a tidy shop. There are rules. I have swag from Neo4j that I'm going to give out. If you ask me a question that makes me look smart, you get swag. If you make me look dumb, you get no swag, and I'll resent you for the rest of my life or yours. All right, so the first question is, what's 221B a reference to? You in the back, awesome. You get a t-shirt. Neo4j, it's beautiful. Sherlock Holmes. So they're also a series of books, but the BBC series, if you haven't seen it, it's amazing. And the season 3 premiere, they just announced this yesterday, January 19th, 2014. And if you'd asked me yesterday, I could have told you the countdown. I don't know if you guys have ever seen Hillary Mason talk. She was the chief data scientist at Bitly. She's at some VC now. She's a brilliant speaker. So she's done a series of articles on how to give tech talks. And I'm generally pretty sucky at it, so I stole her agenda. So the first thing I'm supposed to do is introduce you guys to the ideas. So the first thing is, what is a graph? Does everybody know what a graph is? Like, it's probably a pretty technical crowd. Why should you care about graphs? And then why care about a graph database? So the first thing is, graph has probably the simplest definition. It's a series of nodes and then relationships that connect them. And the nodes can be anything. It can be a concept, an object, anything. And then the relationships themselves can represent anything. So a graph is a very, very flexible structure, and it's easy to think in. Why care about graphs? Because they're everywhere. I have a whole bunch of stickers that will tell you that, so come up and get them afterwards. But really, if you think about it, and actually the guys from Neo4j always run around and say, reality is a graph, which there's some stuff to support that. But so of course the canonical now is social networking. Twitter, Facebook, it's all a graph. They're all mining you and using you. I like this picture because except for MySpace, I don't know if any of that is still around. This is really interesting, and if I could get on the internet, which I wasn't able to, I worked for a bioinformatics lab at MUSC, and people studying genomics and metabolic pathways, they've started modeling everything as a graph, so that, and it's one guy in particular at MUSC has done a lot with this and has come up with some interesting potential for detecting cancer earlier, things like that. So it's pretty fascinating. Then, of course, there's the whole national defense thing. Has anybody read any of the, like Osama bin Laden, how they tracked him down and things like that? There's been a couple of articles that literally refer to his capture as like, we just walked the graph. From the financial transactions to we identified this person to this person to this person. And if you remember 9/11, you heard this statement over and over. Go out and Google it, and all the things are, we just didn't connect the dots. And so there's been a lot of focus on kind of graph theory and almost kind of what Andy Hunt was talking about, context, like understanding the interrelated relationships of all these things. So, okay, why care about a graph database? The first thing is if you talk to somebody who's very performant-minded, they're faster than relational databases for traversals when you get to a certain level. Think about a relational database. You have some type of object that you're trying to interrelate, and then you have that join table. And so you get join after join after join as you kind of walk down, and that gets to be slow after a while. And there's a couple of papers on this, and then like MySQL posted one rebutting, like it's, you can't get anywhere with benchmarks. But this is what I really like. It's whiteboard ready, and that's a phrase that you see Neo4j toss around a lot. Think about when you first go into design a program or something. You go up and you start writing your concepts down and then drawing arrows to them. And so to me, there's just no impedance mismatch, right? I don't have to go from my concept and then plan out how I'm going to do my joins, and then it's just I have my concept, which can have properties, can have my relationship, which can have properties, and then whatever I'm connecting. So to me, it's just a simple, easy way to think. All right. So that took a little bit longer than I thought, but we're going to move along. So now that I've introduced you to the idea, we're going to have a high-level overview, and we're going to dive into some of the technical details. I combined them because even as I was doing this presentation, I was boring myself. So this is the 5 things you need to really know about graphs to get started. And we're going to do these in Neo4j using Cypher. So we've covered what a graph is, blah, blah, blah. What Neo4j really specializes in is doing property graphs. And so you can just have a graph where you have a node relationship, and that's it. But what Neo4j really emphasizes is a property graph, and it has some distinct characteristics. The first is each node, each relationship has a unique identifier. Each node and relationship has properties. And then all your relationships have a type. So if you think about Twitter, Tom follows Bob, and the follows is the type of that relationship. And then and then the other thing is relationships are directed. Just like Twitter, Tom follows Bob, the relationship is from Tom to Bob. And unless Bob follows Tom back, then you can only essentially walk the graph from Tom to Bob. Does that make sense? We're going to see an example of that. And then that's it. So it's really simple. So we're going to make a graph based around the Avengers. Everybody's seen that movie, right? I think it made like $2 trillion. It's very, very important to know, though, this is the cinematic Avengers, not the comic book Avengers. There's a big difference, and that's very important. So this is kind of the graph I started with. Again, just whiteboard ready, just kind of drew it out real quick. We're going to modify this as we go just to kind of simplify things because that was a lot and I got lazy. So we're going to go ahead and put the nodes in. It's really making me nervous, you taking pictures. So again, a node is any concepts or objects that you wish to depict as having a relationship. There's essentially there's no impedance mismatch. Whatever you can design, whatever you can imagine in your head, you can build out as a graph. And then again, they're going to have a unique identifier and have key value properties. I don't know why I'm totally ignoring you guys, but I just feel more comfortable this way. So the first thing we're going to do is look at Cypher. I'm going to take this. No, I wasn't brave enough to live code in front of you. Just going to type this in, and then, so if you look at, crap, I can't point, can I? So again, just like you have an insert statement in SQL, you have a create statement in Cypher. So here we're just saying create. Phil Coulson is the identifier. And then here you see the properties. Does everybody know who Coulson is? No? All right, I'm just up here alone. All right, that's fine. And then here's the properties, right? So he has a name, and then I just gave him a description. And then I returned Phil Coulson, and he's Phil Coulson. And so you see here, node, this is his underneath unique identifier that node is referencing him as, and then those items. And so we can, this is another, we're going to expand on this. We can return him just by doing a start from, and then that n becomes a value that node star is assigned to. So it says any node that's in there, walk the database and return it. So here we're just, right now, only Phil is in there. So it's a really simple language. I mean, essentially, to me, it's simpler than SQL because you don't have to have the insert into values and things like that. You just, it's document storage in a way that you can just throw whatever properties you want in there. In 2.0, they are adding sort of a simple schema if you want it so that you can kind of enforce standards, but and they were actually a little bit upset when I told them that I was just using 1.9 because 2.0 is remarkably better. So we're going to go ahead and just add all of these. These represent all the nodes in our thing. So now we can see that they're all in there. Yeah. So, and again, simple statement, just create this node with these properties. And then you don't even really need the return. I just put that in there so you could see. So it's a very simple language. So let's add them. So the relationships, the connection between the two nodes. Again, Neo4j, kind of property graph focused. They have to have a unique identifier, have a type. They have to be directed. Even though you can work around that, and I'll show you that, have key value properties. So
what does type mean?
It's that follows. So Tom follows, so you're typing the relationship, which is...
Is that just an arbitrary string, or does it enforce keys that must exist as properties?
No, there's no, you can create relationship types on the fly, which is really nice. There's a version of the database of the Neo4j graph database I built out for kind of the all things open that I'm not using that one because it got all messed up. But like the further you mined, like it was just easy to throw new relationships and detect new links between people. So it's very powerful. So here we're going to create a relationship with no properties just so we can look at it. So again, all we're doing with that start is anytime you see the start, you're identifying the nodes that you're concerned with. Sometimes it's star, you want to operate on all of them. In this case, we're saying find Phil Coulson with that node auto index. Basically identify the node that has the name Phil Coulson, and then right below, assign Director Fury to whatever node has the name Director Fury. I can't believe I'm on a stage saying all this. Really wish I had picked a more respectable graph. So below that, you see the create statement again. In this case, we're saying create the relationship between Phil Coulson, Nick Fury. Coulson works for Nick Fury, or Director Fury, sorry. And then return R. So now the relationship is there. You can see below there were no properties. So the properties, the curly braces or mustache or whatever people call them, handlebars, are empty, but it has a unique identifier. And then we can see that it's in there, and it's this particular, and we'll see this particular kind of statement come in handy a little bit later. So we're saying this is how you do pattern matching, walking over the graph and return me any node or node relationship that matches this pattern. So here we're saying start with Phil Coulson, match any node relationship where Phil Coulson works for whoever, and then return director. Does that make sense? See, Cypher's simple. This is why I like it, because once you get into SQL and stuff, you're like, oh, but this is simple. So all it does is there's only one relationship. It matches, says the director, returns it, Director Fury. And director could be anything. It doesn't, like, I probably should have just made it a D or something to emphasize that. All right, the next thing we're going to do, and then we're going to move on quickly, is if you want to add a You can see here where you're creating the create Iron Man. I really should have picked something else. So Iron Man knows Phil Coulson, and then the attribute is, well, what's the basis of the relationship? And it's respect. But this is actually kind of a bad model if you wanted to doing matches on a node, a relationship type and a relationship attribute is much slower than just doing it based on a relationship type. And you can, in your queries, group relationship types into kind of an overarching thing, so it makes it easier to query rather than doing this basis of respect. It should have just been, the relationship type itself should have just been respect. Yes?
Node auto index.
So let me answer that at the end. So I'm going to go ahead and add the rest of the relationships real quick. And we're going to hurry on. So I didn't add all the relationships, and I dropped off a couple members because I wanted to illustrate a couple of things about graphs with this. But and we'll see that now. So the first thing is traversal, and that's when you just walk the graph. And you can either walk the graph with no criteria, which just means give me all the nodes, or walk the graph with, like we saw before, whoever the director of Phil Coulson is, return that node. So let's jump here. So let's go back. So what we're going to do is we want to get from Iron Man to Director Fury, right? And remember, relationships are directed, and we created a relationship to Iron Man, to Phil Coulson, to Director Fury. Okay, so if we were enforcing a directed graph, that we can see that that's possible. So, and if we run this query, you can see it returns the nodes along the walk. So from Iron Man, damn it, I should have picked something else, to Phil Coulson, to direct, thank you, to Director Fury. So this is very, very handy in, we're 221B Labs is actually, we're talking to a conference, much like this one, where, and it's not, I don't know if I want to do this yet or not, but where recruiters are coming, much like here, and they want to know, like, so I know this person but I want to talk to a C# developer, let's say. So, and this actually just happened today with, so tell me, you've mapped out the people who've come to this conference, walk me through how to meet this person. So give me an intro. And that's not just handy for recruiters and developers, but that's handy in a lot of social, I mean, that's what LinkedIn is based around, right? Except, I don't know, I have people who knew me 11 years ago recommending me for technologies that didn't exist then, so I don't know about LinkedIn. So real quick to illustrate the other thing is, so what we're going to do here is walk from Director Fury back to Iron Man, right? And you see, I'm going to have to point. It's driving me crazy. I'm used to talking on a whiteboard. So again, we're doing the directionality from Director Fury to Iron Man. And remember, if you look, the arrows are going against, right? So there is no real way in a directed graph. So you get 0 rows. What Cypher lets you do, though, screwed this up. All right, let me just do it here real quick. So where you indicate the directionality with that arrow, all we're going to do is right here. Can you guys see that? Probably not at all. All right, we're going to get rid of that. And so we're saying essentially that's saying we don't care about directionality. So just return me the path, and there you go. From Fury to Coulson to Iron Man. And again, all this stuff is meant to be used on much, much bigger graphs. I just kept it small because I was lazy and to make it simple to see. So the next thing is, so we did that, is centrality. And this is, this gets a lot, if you read any of the books and then some of the papers, this is argued about a lot. So basically what it is trying to determine who a particular node, how much influence a particular node has, or how much power they have over the individual network. And so one of the cases, and I think it was in the O'Reilly, it was either in the social network analysis for startups book, or they have another, the mining the social web or something like mining social network. It just second version just came out. It's fantastic. Definitely grab it. But the example they give is Justin Bieber. Like, there's no dignity up here. So Justin Bieber, who has I think he has the most Twitter followers, I guess. At least that's what the book said. So, which I think is shameful. I mean, we're really shame the open source community. I think our whole society should just be shamed for that fact. But what they were talking about was during the Arab Spring, Justin Bieber, a couple of times he tweeted, I guess, about the Arab Spring. Do you guys remember the Arab Spring? And Twitter played a huge role, and so did Google. Google was actually, they did an amazing things for everyone. But so Justin Bieber would tweet, but the people that follow him, not surprisingly, didn't retweet his information. So while he may have this, if you were to do degree centrality, which is just counting the number of links that somebody has, he by far is probably the most powerful person in the Twitter network. But there's another measure of centrality or power, and that's how quickly you can disperse information. Well, he sucks at that for important things. I don't know, maybe there's some movie or something that he can, but there was actually a Google executive who had far, far, far fewer, but he was Egyptian, and anything that he tweeted was instantly retweeted. So in that case, he had far, far more power. So this idea of centrality is always fluid. And we'll look at another thing in a second. So degree centrality, here we're just going to stick with this one. And it's very, very simple to do in Cypher. So we're just going to say match all the nodes, walk them down, match any relationship with that R, return the node, and then count R as the degree. And then we're just going to order by discrete. Let's do this. Yes. Right now, that's all I haven't seen it used with. Sorry, I didn't try this but you can see there is some other. It's a much, much smaller graph database that is talking about implementing it. And then if you use I don't know if Jessica McKellar's here, another really, really great graph database. And actually, if you're doing any of the O'Reilly books or about any type of mining, are all Python based. And there is a graph database, if you're hate the JVM, called Network X that is fantastic. And actually, some of their, it's actually to a degree, a little bit easier to use, I think, in some cases. It's an appealing, and they're talking about adding Cypher. I've seen a couple of. But you can see we sort of made Phil Coulson the center of our graph just because, I don't know, I love Phil Coulson. So you can see he has six connections overall, and everybody else has far fewer. So you would think he was the source, based on degree centrality, he's the most powerful. But there's also this idea that, I think it's the gray cardinal, idea, and that is anytime you have somebody who's highly connected, there are times that that person's being controlled, right? So, like, we all know, if you've watched the movie, Director Fury is in charge, right? He's the man. So, but in this case, he has less links, but Director Fury is the Gray Cardinal. And that's another thing that they actually looked for when they were hunting for Osama bin Laden. And so I saw some guy give a talk. He's like, basically, anytime they droned somebody, they were hunting Gray Cardinals. So, but that's another thing to look, is that often the person who appears and this is a big generalization, but you read this a lot. Anytime there's a person who appears to have the power, there's usually somebody behind them in at least social networks. And then you actually sort of see that in cancer study too. Like, you identify a particular interaction, and it's not really that interaction, it's something else. So it's kind of interesting. So we did traversal, we did centrality. Coulson lives, which we now know thanks to Agents of S.H.I.E.L.D. So example that brings now I'm supposed to bring an example together. So here's what I did. This might be a little bit creepy. So what I did was, and Twitter and GitHub should sponsor me. So what I did was, I went to Twitter, grabbed all of the followers from Twitter, and then I made some assumptions. One, that everyone who follows All Things Open are attending the conference, so I'm just assuming you're here. That a person's Twitter handle is the same as their GitHub handle. I mean, those are pretty rock solid assumptions, right? And then I was just like, people who don't code aren't interesting. So how many people, after the Avengers and that, I'm sure, how many people have I lost? So I went and just pulled that, got the API limit exceeded a couple of times. So I started off with myself, not that I think of myself as the center of all things open, but because I knew kind of the social network surrounding me, so I just wanted to verify. So what you're looking at right now is starting with me and then walking out, okay? And this is where we get to shaming one of my friends. So you can see me right there. Tom right here is my boss, and we each follow each other on GitHub. I didn't count Twitter follows, right? And then the other nodes that I said, and this is a bimodal graph. So we have nodes of GitHub users and then nodes of languages, because I was interested to see which languages were most represented here. And if you actually look at the conference schedule, you can probably guess. I mean, given that there was an Angular and a Ember talk, and then there's going to be a Node.js, which you guys should all go to. Jeremy Martin's giving me is brilliant. So you can see, so the follows links, and then we have the programs links. And then if we walk out, it just gets progressively more. And so I don't necessarily want this for recruiting purposes, but I think it would be interesting at conferences if you were given a graph, a social graph. And I'll actually take all this and I'm going to push it into a blog post. But one of the things I wanted to walk through was, first, just because Clojure is near and dear to my heart, you can easily, just as you could with a normal database, say who are all the Clojure developers. So there's only 5 of us here. I think OSS integrators are a group. It shames me that Jed Schneider is mentioned in this list. I've seen his code. So, and then it's interesting, if you look at, and I wish I had messed up this other database, if you look at the people who follow each other on Twitter versus GitHub, I mean, the density is much higher for ATO than if you look at it for GitHub. So I just looked and was like, well, who all follows each other on GitHub? And it's not many of us, right? It's a grand total of these people. But I would like to point out something. Just note this column right here, you'll see that there's a name missing. All right, so the next thing was, well, who all follows each other? So if I follow you, you follow me back, right? And that's only Tom and I follow each other. We have a progmance or a bromance or whatever they call it. But yeah, so there's not a lot of reciprocality here. And then if we want to look at centrality, look, Jed Schneider is he's right back there. I wanted to shame him. Not really shame him, but so he is the heart of the developer legions at. But I would like to point out something. We need to rise up against Jed. See, this is the fun this is what I was talking about, fun. Like, you can just do evil things with graphs. So these are all the people who follow other people. So we all follow Jed to a degree, but Jed does not follow anybody back. And I only bring this up for two reasons. One, it's fun to humiliate Jed. And then two, it is interesting to look at these things as far as a social network, right? If you follow somebody, but they don't follow you back, that speaks to your relationship, right? And sorry. Jed, I'm hurt, Jed. What this is called is when you have one node that follows another node, it's a dyad, is what they call it. And then when there's three, there's all these characteristics. So in a relationship where it's unbalanced like that, and they've proven this out a number of times, always with fraternities, which is really odd. They literally bring in the fraternity brothers and like, on a scale of 1 to 5, how much do you like this person? How much do you like this person? They do click detection. But what they found is, in a relationship that is uneven, like Jed and I have, it's a very fragile one, and it falls apart usually after about 2 to 3 weeks. So Jed, we're over. And that's another part of, and I didn't really get to dive into this, but there's a whole series of characteristics based on dyads and then triads. So what they find out is in a reciprocal dyad where you follow somebody and they follow you, the relationship tends to become stable. But you tend to lose your identity. One party or the other tends to lose parts of their identity. And then when there's a triad is much, much more stable, actually, which sounds like I'm advocating for Mormons or something. And I don't care what you do with your, so I'm not taking one side or the other. Please don't throw me out of the conference. What happens in a triad is you actually people tend not to lose their identity, but a shared identity form. So this stuff is fascinating and it's fun. And then when you know that type of stuff, you can abuse it and manipulate people. Crap. So another type of centrality besides the whole Jed debacle is which languages are most represented? Out of all the developers, what language is most programmed in? Big surprise, JavaScript. God. Ruby, Python, Java. It actually almost follows the language ranking on GitHub, doesn't it? Yeah. Poor closure down here, but thank God it beats CoffeeScript because that is just a shameful, shameful language. Well, I'm going to go delete that relationship. I should have done that ahead of time. That's the other reason. If you know this stuff, you can manipulate the results. So I think Jed's giving a talk on that. I wouldn't go. So it is kind of interesting. So I was actually talking to one of the people who run this, and they're like, that's fantastic if we can take that and go to our sponsors and say, you're going to have the bulk of your audience, your developer audience, speaks JavaScript. And if you're like, I don't know, whatever foundation is birth node, just kidding, Jeremy. They might that might cause them to want to sponsor more. And then I will note I don't see Relevance who, I think they're Cognizant now, that does closure, so I can't really make fun of it. And then the other thing is, what's the degree of centrality around Who programs in the most languages? Is Eric, I don't know if he's even at the conference again. I made those two big assumptions, but Eric Martindale, we could go down. So that's kind of interesting. Jonathan LeBlanc, I know he's actually following me. I'm sure I'm making him look good. Tom Wilson, 4 languages. I think he briefly flirted with CoffeeScript for a while, and then so that's there's a lot more stuff you can do, but it's creepy. So I'm not going to show it. So this is what I was thinking about. So I'm supposed to wrap this up with an exciting conclusion. So this is my exciting conclusion. Were you guys all here for Andy Hunt's talk? Yep. About the mind maps? If you look at a mind map, and this is under Creative Commons, but I was supposed to give him credit, so whoever this is, I'm sorry. If you look at mind map, this is a mind map. It's a graph, right? I mean, that's what it is. You're drawing, you're putting concepts down and then drawing relationships, right? And what Andy talked about is this is part of the creative process for creating brilliant new ideas. Right, so what I was thinking was, you don't want to characterize things too much while you're doing this, right? Like you just want ideas to flow. But once you're done, once you've kind of finished the creative process, it'd be interesting to kind of capture it in a graph database, right? To capture that. Capture this mind map, these brilliant ideas. Again, this is where, real value is supposed to be created. And then you can mine them and share them. Even if, if you had completely different relationship types in your mind map than, say, I did, I mean, you could take these and start to bring them together and write kind of rules and things like that. And so you could, by combining these, do new connections and new knowledge could kind of emerge. So I don't know. And I started to actually work on this a little bit last night, but then there was bars and girls with hula hoops and I don't know, weird stuff. So so this is my exciting idea and something when I get back, my partners in 221B will be like, just focus, just shut up and focus. So heavy, right? So we're done. Q&A, remember the rules. I got 3 books. I'm not taking them back. Yes?
So you showed an example of detecting dyads in the graph that you built here. And obviously there aren't any triads if there's only one dyad.
Yeah.
But how would you detect cliques larger than 2?
There's a couple of algorithms. I can't remember the name of the kind of canonical one that everybody implements, but if you use Network X, it's literally say like dots click detection or something like that, and it returns. Neo4j, I know you can use there's a Jung library, it's JUNG, that will interrupt with Neo4j, and it has basically every type of algorithm that you could, and so you would use something like that. But if you go onto Stack Overflow and read, it's not a trivial, and it's computationally intensive, but it is interesting to see who are the clicks and who aren't. I really wish I could have access to like some big company's email. Like I think that's the biggest untapped graph. So do you want a book? You get a book, all right. I'll give it to you afterwards, and please take as many stickers. Yes? Yeah, so you just create, so that was Pepper Potts and Iron Man. So if you look here, this is the relationships can go both ways. Can you guys all see that? So yeah, you just create, and I wish is the Twitter guy here? Like he probably could comment on like FlockDB is one of their, he talked about it yesterday. They built it specifically for social network analysis. Yes?
So you skipped some of the math stuff related around graphs, but I'm interested with the database if any extra awesomeness comes out of detecting Euler paths or circuits or trees or complete graphs, anything like that that adds something.
When you say like extra awesomeness?
I don't know.
So they do, I have it on my Google Keep. They talk about, and it's these benchmarking wars right now over who's faster, but yeah, supposedly that type of is faster in graph databases. Supposedly. It's one of those things I don't know enough about to really, and you read one thing and you're like, oh, well, that sounds right, and then you read another and it's, but yeah. You didn't make me feel too stupid, so you can have a book too. There's one more book, so one more question. Yes?
He actually stole my network analytics question, but are there any like really awesome libraries for making visual representations of this in a human readable format?
Yeah. So one, it's called Sigma.js. If you want to do it on the web, there's Sigma.js, there's there's a lot of those types. And then what I'm showing right here, I should have mentioned this, is NeoClipse, which in 2.0, they have I forget what they call it, some view browser. It's beautiful. I mean, it is beautiful. And then I'm not a very visual person, so I'll put like the .viz files and just Google actually has a API. You just run it through and they create the stuff for you. But yeah, the Sigma.js is pretty nice. For whatever reason, I've drawn to that. So, good question. I should have planted people. So I think I've talked way over. Oh, sorry. Somebody else have a question? Oh. Right here? Okay.
Yeah, so if all relationships are directed and you actually want to track properties on relationships, how do you deduplicate that or know which directed edge?
Oh, yeah, they're duplicated on. So you're saying if,
Yeah, so if it's actually an undirected relationship and you want to track properties about that, how do you know which edge to look on the property? Just duplicate it.
you duplicate it. That's what I've always just duplicated it. Yeah.
Okay.
So, well, are you saying properties on the nodes or property on the relationship?
On the relationship.
Okay.
Yeah.
Yeah, I mean, if it's undirected, then it's just, if you do an undirected, then it exists either way for both, so it's just one set of properties. You don't have to do the double with the directed, like the Tom follows Mark, Mark follows Tom. Or am I misunderstanding your?
Is there a way to make a two-headed edge?
Yeah.
Oh, okay.
Yeah. All right, I'm going to end this because it's getting pain. Damn it. I'm just kidding. Oh, okay.
Are there any tools or best practices for converting existing relational data to graph data
I haven't seen anything, but that would be awesome to write. Like, that's an interesting problem. Are there any tools to take an existing relational database and go to a graph database? And that would be pretty, yeah. I mean, just by looking at foreign IDs and things like that, you could probably pretty easily generate and then migrate the data. Yeah. Yeah. I wonder how Twitter did it, because I know he was saying they were on MySQL and then went to FlockDB. It'd be kind of, all right. I think that's it, or they're going to kick me out. And please come get stickers. They sent me 1 million.